We launched this device a year ago, and in order to celebrate that, we created a video. The video is not the true story of our company. The video is our highlights. You'll see a movie star. You'll see the debonair Grant Stevens. You know, we have had a great year since we've launched, but this is not our story. Our story starts with failure. I'm very serious when I tell you. 5 years ago, when we had the idea for Juvasonic, we failed over and over again. I would leave the lab dumbfounded by the data. Nothing came out like we expected it to, but we learned from that. We pursued truth, and that's the key for you if any of you are an innovator. You have to learn from the data. It's a really interesting story. I met a guy named Bruce, an engineer from NASA, 5 years ago. He wanted to come to my lab to tell me his goal, and his goal was to create a device to deliver insulin into the skin without a needle. So I waited for him. It was a Sunday afternoon, and I'm in my lab going, what the hell am I doing? And I'm waiting there, and Bruce parks his car. And it takes him like 6 minutes to walk from his parking spot to the door, the vestibule. I'm like, why is he taking so long? And he has a cane. By the time he gets to the door, I realize most of one of his foot is amputated. Bruce had insulin and diabetic foot ulcer. His foot was amputated. And he said, Sanjay, I have a way to deliver insulin into the skin without a needle. It uses ultrasound. So I wrote Bruce a check, and he sent me a prototype. And we tried. It's the first technology on this slide. And it didn't work. I left the lab, hung off a martini glass in my basement, going, what the hell is going on? For 2 years, we couldn't get ultrasound to work. Despite what you hear and see about Alma-TED, and I'm sure it's an amazing device, it's also $150,000, we could not get ultrasound to work. So I went back to the basics. We looked at iontophoresis and electroporation. We couldn't get them to work. So I said, look, we must try microneedling. The leading microneedling company is here in this room. We love microneedling. We, in fact, find microneedling to be very complementary to Juvasonic. If you look at the history of microneedling, it goes back millennia. It goes back to the Chinese literature, the Egyptian literature, and then, of course, the brilliant skin pen here. So let me show you what Juvasonic is. It's a device that you can hold in your hand. Here's a cartridge. We focus on delivering exosomes, PRP, growth factors, peptides, you name it. You fill this cartridge, you put it in the device, you turn it on. It has red light, hopefully it's on, and blue light. And I can put it right to my face. No pain, no needles, no downtime. It doesn't transect the hair follicle, and it delivers serum past the stratum corneum. And why is this important? It's very important because it's illegal to inject exosomes in the United States. It's illegal. It's not a question of on and off label. There is no label. Juvasonic solves this problem. I'm going to go through some images. On the left is a baseline image. We're comparing topical application to Juvasonic. The red area that's outlined shows the exosome. The image above, the topical application, looks like baseline. Exosomes appear as hypoechoic in this ultrasound image, and they pass the stratum corneum when you use a device like Juvasonic. Look at the red region of interest. The image on the left is a baseline. Following Juvasonic, the stratum corneum gets disrupted, and then 15 minutes later, almost like clockwork, the stratum corneum reconstitutes. So let me tell you the big aha moment. And I'm going to tell you the secret sauce, how this device works. It's so simple. It works with 3 things happening at the same time. Number 1, the tip has a texture to it. It creates dermabrasion on the skin. The second is that there's vibration that helps open up the stratum corneum. And the third is that it works in the delivery of a serum. When you do all those things together, you can enhance topical absorption of cosmetics. This is my favorite image. It's the Van Gogh Starry Night. The image on the left is the stratum corneum closed. The image on the middle shows the disruption of the stratum corneum. Those blue channels are not channels. The blue channels are hair follicles that are saturated in the exosomes. Exosomes are smart, and in order for them to work, they have to get to the base of the hair follicle, and that's what happens. And then on the far right, the stratum corneum reconstitutes. Here's some of the clinical imaging, the cohort at 4 and 6 months. You can see hair density, hair caliber, and also reduction in inflammation. Global image. This is, when I first showed this image, I said, this is an image of my wife's tear trough, and then everyone knew how old my wife was. So this is her baseline image. Following Juvasonic, you see the stratum corneum fenestrates, and then on the right it closes, almost like clockwork. God in evolution made our skin to be a barrier for a reason, and with a simple device like Juvasonic, we can address it. This is the next product that I think that's going to become big. I'm surprised I didn't hear it today. It's called Clotho. Clotho is a protein, a gene, and can also be a hormone. This is me getting treated. I'm 62, and you can see that the Clotho gets past my stratum corneum. Clotho is a very big molecule. It's 130 kilodaltons. So it is much bigger than the 500 Dalton rule. We're able to show it get past the stratum corneum. Innovation. Image on the left is the treatment of filler nodules. This was done with calcium hydroxyapatite. The image on the right, we filed the patent today. It's for the treatment of dry eye with Juvasonic. We've been on the market for a year. We've sold 1,200 devices. We're a startup, we're a small company, but we're north of $1 million in revenue. And we did that with 0 sales reps, without 1 full-time sales rep. We're looking for growth capital. We need partnership. We know in order to get to the next place, we need to partner with someone. Maybe that's someone in this room. Thank you.